So we're going to talk about the seatbelt pretensioners today and the components of the airbag system. We're also going to be looking at anti-theft systems and some other features in our infotainment system. So we'll finish off chapter 57 today. I also have a couple of videos I'm going to show you. One is where we're using airbag technology in another industry. And also I have the Volvo video on the pedestrian airbag and the development of that. And so I have both those videos also for us today that we'll take a look at. So airbags are something that we kind of take for granted. When they first came out, there was a lot of fear about airbags. People didn't want airbags in their car. Like with a lot of new technology, the technology was worse than what it was trying to, the problem it was trying to solve in many people's eyes. So because it was new, people were very leery of it and didn't want it. Amazingly, we had the same reaction to seatbelts when seatbelts first came out. It was the anecdotal of the one person trapped inside a burning car, not the hundreds of people that are thrown out of a car and killed. So it was, so again, we feared seatbelts and didn't like seatbelts when they came out. We didn't like airbags when they came out. So this is very common with new technology. I don't think anyone in the room today has a problem driving a car with an airbag in front of them or driving with a seatbelt on and have those fears because we've accepted it as part of a vehicle and part of the technology that comes with the vehicle. So a lot of people are reluctant to work on airbag systems because they're afraid they're going to deploy the system. And again, we hear the stories, right? That, oh, someone did this and the airbag exploded in their face, or the airbag, system deployed, or they hooked up the battery and all the airbags went off. If you're following procedures and using good common sense practices, that's not going to happen. The airbag is an electrical circuit like any other electrical circuit. The main difference when diagnosing an airbag system is I cannot use an ohm meter to check for an open through the airbag or through the pretensioner or any of those things, because there's enough current supplied by your ohm meter to potentially detonate the airbag. So we diagnose these by substitution. If I have a code for an open circuit for a seatbelt pretensioner or for an airbag squib, what we normally do is go into where that airbag is or pretensioner connector is, disconnect it, and install a resistor of the correct size in place of the seatbelt pretensioner or in place of the airbag, and then cycle the key, let the computer do its self-test. If it says, hey, everything's good now, we have a bad airbag. If the computer still says, hey, there's an open, now it's time to check the wiring, and we would do voltage drop testing for that to find out where that's at. So that's where we're different than light bulbs or other things or motors or solenoids that I, would be allowed to put an ohm meter on. Not necessarily that it would give me good advice, but I'm not going to hurt anything by doing it as long as I've isolated it. With airbags, I can actually set an airbag off with an ohm meter. So we're not using ohm meters on these systems. We're using voltage drop, we're using signal simulation, we use a lot of other things, load substitution, but we're not going to be using an ohm meter. So that's the biggest thing. The second biggest thing is if the airbags are deployed, odds are you need to replace the airbag module. Most manufacturers recommend it because the flight recorder for the vehicle is in the airbag module. So it's a one-time use. So it's going to grab data based on what was happening moments before and moments after the airbags are deployed. So, for example, Tiger Woods was just in an accident several months ago in his SUV. And the report came back exactly how fast he was going, whether he had his foot on the brake, had his foot on the gas, all of these things. Well, where did all that information come from? It all came from the airbag module because the airbags were deployed. So the airbag module is constantly monitoring what's happening. It only records the data once the bags have been deployed. So that can only happen once. We only get one data event. The other is that the airbags, once they're deployed, the transistor or the switch inside the computer is now connected the circuit to deploy the airbag. It doesn't reset. It just stays there. It's a one and done switch. So once it's commanded the airbags to deploy, it records the data for that deployment. Now, some vehicles have the capability of applying multiple airbags or the same airbag through multiple squibs, because some, as we'll see, some airbags have two squibs in them. Each time a squib is fired, it's going to grab that data. So if it has two firing events, we're going to get two groups of data. For example, the airbags were deployed, and 300 milliseconds, we deployed these airbags, and you'll have the time and the data between those two. And it may have things like G-force, has what is the brake pedal applied, is the accelerator pedal applied. There's a lot of information that's available to an accident reconstruction or forensic person from these boxes. We can normally not access the information in those boxes. Either it requires a special scan tool that only does that, or in the case of some manufacturers, it has to be sent back to the manufacturer and the manufacturer will retrieve the data. So that's not something we have access to with our normal diagnostic tools. We have access to the airbag system, and I can fix the airbag system, but we don't have the information. We do not have access to that crash data. So seatbelt pretensioners are used to tighten the seatbelt in a severe frontal accident. Well, actually, we'll use the pretensioner sometimes in a minor accident in lieu of firing off an airbag. Because many times all we need to do is secure the person. We don't need to explode an airbag in their face. So again, it comes down to manufacturer, but many Europeans will fire the pretensioners in lieu of an airbag at low speed collision. Three types of pretensioners: electric, mechanical, and pyrotechnic. Ballistic pretensioner relies on an explosive charge that is detonated electrically by an actuator. So these are the pyrotechnic ones. These are the ones that we replace the most often. A lot of European vehicles use these. And I think I have a picture of one coming up. Mechanical systems rely on inertia to move a sensing mass. So these are the real old school ones. Once the pretensioner is triggered, a ratchet prevents the belt from loosening. Cannot be reused once the seatbelt is removed from the buckle. So depending on the system, if it's just one that relies on inertia, many times they'll reset. If it uses pyrotechnics, it's done. And some of the electrical ones will also reset. So again, that's why it's important during an accident or after an accident to find out what the manufacturer recommends be replaced. So here we have a couple of them. Here's a regular seatbelt pretensioner with a gas generator. What's interesting about this is it shows it pushing. All the ones I've seen have a cable, and they actually fire this way, and the cable pulls down to tighten the belt. So it's interesting that they use this in the book. I've never seen one that looks like that. Here's a pretension motor. Here's an electronic one, or electric style. Another thing that we see in some newer vehicles is rip stitching in the belt. And this is so that stitching will pull at a controlled rate. So not only do we have the slack out, but as my body wants to move, if I'm heavy enough and there's enough inertia, we'll start ripping the stitching in the seatbelt where the seatbelt is layered, and it comes out just a little bit at a time. So it's a controlled movement. And so newer style seatbelt pretensioner uses the electric motor to pull the slack from the seatbelts. It's reusable and can be activated repeatedly, as I already mentioned. Rip stitching in seatbelts in conjunction with an airbag and seatbelt pretensioner allows the occupant to move forward into the airbag at a controlled rate. Seatbelts must be replaced once they've had their stitching ripped. So this is not something you can restitch or whatever. This is one and done. So we have quite a few sensors throughout the vehicle. Normally they're mounted up front, in the center of the vehicle, and possibly in the rear. So crash sensors can be installed in various positions. So sometimes they're on the frame, sometimes they're right on the strut tower, sometimes they're under by the radiator core support. Manufacturers also will normally place a sensor in the PCM. So the PCM normally, it's not the PCM, it's the ABS module or SRS module, not the PCM. Again, the book overuses PCM, but it's the SRS module. The SRS module is going to have a couple sensors in it. One is a staffing sensor that allows the system to activate. And it also normally has a G-force or a yaw sensor in it, which allows the computer to know from what direction you've been hit or where those G-forces are. And that's pretty universal. Just about all ABS modules or SRS, I'm not ABS, SRS modules or airbag modules have that in it. Side impact sensors may be located in the door sills, B-pillar. Mini puts them inside the doors and sealed them. And if the pressure changed, the airbags would go off. So there's some precautions on some of the minis for pulling the door panel. Because if you do it with the key on, you can set the airbag off. SRS control module deploys the relevant bags depending on the information from the sensor. So an early system with one bag, either we deploy or we don't deploy. Once I start getting 2, 4, 6, 8, 12, 20 bags, now I have to have a more adapt strategy to figure out which bags need to be deployed and when, based on how fast we're going and the amount of energy that we're hit with and in what direction that energy is coming from. And so we're, a lot of calculations are happening very, very quickly to decide which bags need to be deployed. If a collision is in the front, the driver and passenger's bag will normally deploy. If the collision is on the side, the sensors determine whether the seatbelt mounted airbag or curtain airbags for one side will deploy. Now, what's interesting, when I was in my accident, I got rear-ended by someone who was watching their cell phone and not what they're doing. So they hit me about 55 miles an hour, shoved me into the truck in front of me, and it deployed the side curtain airbags and my front airbags all at the same time. I don't think it didn't deploy the passenger front, but it definitely deployed the driver's side curtain. I think it deployed both side curtain bags. But it, protected me. And what was amazing is that none of the glass broke. The front windshield and the back glass didn't break. And this was a little Toyota Corolla. So none of the glass broke. I could get all the doors open. One of the rear doors was a little sticky getting it open. And front and back of the car were crushed. I mean, it was definitely severely damaged. It was a total 2-year-old car. And from what I understand, I was out for about 2 minutes because I was on the phone with my wife at the time. And I said, he's not going to. And the next thing, there was a big bang. And she didn't hear me again on the phone because I was hands-free. She didn't hear me again for about 2 minutes. So, apparently I was out. I remember seeing him about to hit me, and I remember someone next to the car asking if I was okay. I missed the time in the middle. So obviously, I was stopped when I was hit. So obviously a great deal of force in the bags hitting me and everything else obviously caused me to lose consciousness, although I didn't realize it. So, the bag design is going to be really based on the level of the vehicle, how integrated or how advanced do they want to make the design, and also how is the vehicle hit. So it talks about more refined designs. The passenger bag deploys only if there's an occupant in the seat. That's very common. We have a seat belt. We have a occupancy sensor for the passenger seat. On more advanced models, that sensor actually registers a weight, not just to someone there. And then we also started using weight sensors in the driver's seat because obviously we know there's a driver. I don't need to see if there's someone occupying it at this point. When ADAS gets further, maybe we will. But what we want to know is how large is that driver. So some of the more high-end systems will have a weight sensor there also. We're also seeing airbags come in for rear passengers now. So now, again, those occupancy sensors and weight sensor technology we're starting to see in back seats. You know, how big are the kids back there? Who's riding back there? So, you know, this technology is continuing to evolve. These sensors do go bad. The weight sensors go bad. The occupancy sensors go bad. The occupancy sensors are a little easier. They're just basically a high-tech switch. The weight sensors are a little more complicated. A lot of times they'll get a bad spot in them, or you'll get some codes for them. And if you replace a weight sensor, you have to recalibrate the system. So you actually have to have weights to put in the seat so you can calibrate it per that manufacturer's procedure. So some of them may say, we want exactly 55 pounds there, or we want 70 pounds there. And you have to use the scan tool to calibrate the seat sensor based on the 70 pounds that you put in the seat. So we've gotten pretty creative over the years at finding weights to do that, and you know, knowing when we have to do that. But that's something that's not uncommon. And again, it has to kind of sit in that seat area. A 5-gallon jug of water is pretty close to 35 pounds. So that kind of good. And then we put other weights on top of it, and that sits in the seat pretty good. So we've done that. We've done different things to try to get that weight in there. To prevent incorrect and unnecessary deployment, a staffing sensor is mounted within the SRS module, which I meant already. That's like an enabling sensor. Can we have airbags? Capacitors within the SRS module are used to store electricity and act as a battery backup supply. So the SRS module is designed to still be able to deploy based on the charge in the capacitors, even if battery power is lost at the point of impact. We're still going to be able to deploy those bags. So here is an airbag module. Airbag modules are normally mounted in the center of the vehicle, either between the driver's seats up to the firewall, somewhere in that area. Airbag modules are not mounted on one side of the vehicle or the other, and they're usually not mounted too far back. They want them fairly central to the vehicle because they have that yaw sensor in it. So we want to know which way it's going, and we want to sense that equally in all directions. So they normally are, like I said, in this underneath the center console between the driver and passenger seats up to underneath the dash in the center of the vehicle. It's normally where we're going to find an airbag module. Does someone have something? Just heard someone talking. Okay. Some vehicles use a 2-stage side impact airbags. Any of the SRS related devices that are deployed for any reason, most manufacturers require they be replaced. And you can see the yellow connector I was talking about yesterday, yellow connector and the yellow tape over the wiring harness. That means it's part of the airbag system. So they require that wiring to all be in yellow and use yellow connectors. So if you're underneath a seat and you see a yellow connector that looks this color and a harness that's taped over that color, guess what? You have an airbag in that seat if that wiring's going to the seat. So if we're going to work on these systems, generally what they want you to do is power down the system. So disconnect the battery, wait 10 minutes, and then you can work on the system. And that's most manufacturers' procedures. So smart airbag technology uses intelligence to vary the control of the airbag deployment. The improvements include the use of information regarding the severity of the accident, seat position, weight of the occupant, capable of varying the deployment force of the airbag as needed. Adjustments can be performed by diverting some of the gas from the airbag inflation system into the dash, using a dual chamber airbag or using a dual stage airbag. So it just gives it a lot more flexibility to cater the deployment. So early systems were all or nothing. Either you got an airbag or you don't have an airbag. New systems, it's now, do you just need a seatbelt pretensioner? Do you need the pretensioner and an airbag? Do you really need an airbag or a little airbag? Do you need multiple airbags? Where do we get hit from? And this technology is continuing to evolve with our ADAS systems and our radar sensors. So, for example, I think it's Audi. If a car is coming towards you and it looks like you're going to get T-boned, it'll put the windows up and actually drop that side of the vehicle to prevent the car from being flipped over. It'll actually drop the suspension to brace for the impact. And this is all happening in split seconds. It's working on getting the windows up fairly quickly and again, to contain the passengers, to contain things from that side. So it's pretty amazing that how many things we're integrating into not just crash prevention, but how do we minimize the effects of an accident once that happens? So here is a real simple example. Here we're using some ultrasonic occupant passenger position sensors, dual stage airbag, impact sensor, SRS module, load sensor, seat position sensor. So this is just a simplified drawing, not necessarily representing the actual location. I have not had to work on any of the ultrasonic occupant position sensors. I've had to work on load sensors, position sensors for the seats, modules, impact sensors, airbags. All those kind of things are pretty common. So here's what we're talking about, a dual stage airbag. So in this case, it's divided, it's basically one airbag, but two different gas charges. So I could deploy just the 60% charge, the 40% charge, or deploy them both. I also have the ability to deploy one charge and then deploy a second charge moments later. So like I said, in my car, I was rear-ended and then I got pushed and hit the car in front of me. Well, that's going to be two events. So a dual airbag like this might kick one and then kick the other based on being hit and how it was hit and the direction and the impact force. So again, we've moved a long way from all or nothing to really being able to cater. Maybe I need 100% if the driver's 300 pounds, but if the driver's only 100 pounds, maybe I only want 40%. So again, it allows us to protect a wide variety of passengers and drivers based on size and mass and height and all those things. So if I'm diagnosing the airbag system, consult manufacturer service information, ensure all safety precautions. So manufacturers generally want the system disabled before you remove any components from it. So, what do you do before, removing the steering wheel? If it has an airbag, you disable the airbag system before you start taking the airbag off to gain access to the steering wheel. Many manufacturers use a yellow wiring device to denote wiring for the airbag system. I've not seen one that doesn't. Always be aware of the system or circuit you're working on. Make sure you disable any SRS devices as directed by service information. Retrieve codes to identify the location of the fault. So the code isn't going to tell you the location, it's going to tell you the circuit. It's going to say I have a problem with this circuit, whether it is a crash sensor, whether it's an airbag. It's just saying there's a problem with the circuit. From there, we're into wiring diagnosis. So normally what we do is we go to the component in the circuit, say it's an airbag, disable the airbag, install a resistor, have the computer do the recheck. If the computer says everything's good, that proves all my wiring's good, I need a new airbag. If it doesn't come back, then I have a problem in my wiring. If it's a driver's side airbag, the most common thing that goes bad in the wiring is the clock spring, which is the device that mounts in the steering column that allows me to rotate the steering wheel and still maintain electrical connection. And there's a little strip of wire in there that's wrapped up and it fatigues after a while and breaks. Very, very common. Matter of fact, I had to replace the one on my wife's car, even though it didn't have that many miles on it, because Chrysler was having an issue with them. So they do go bad just on normal use. They're also a high failure item if someone's done suspension work or had the steering column disconnect or anything like that. And because it's real easy, if you put it in one turn off, you'll break the clock spring. So entertainment, everyone likes entertainment because we want to be safe. So let me see, save. I'm going to take a quick break and do a couple videos and we'll get in entertainment here. So let me stop my share. Okay. So this is Volvo, and they are going to talk about their vehicle. And this is, I think, Volvo UK or Australia. I can't remember which.
The new Volvo V40 is equipped with a pedestrian airbag. It's designed to help protect pedestrians in case of an impact to the vehicle's front. Made for city traffic, where people and cars share the same space, it operates in speeds between 20 and 50 kilometers an hour. People are soft and cars are hard, and in order to try to cushion the impact, the airbag has two purposes. One, to lift the bonnet to create additional space between the bonnet and the hard components in the engine bay, like the engine. And secondly, to cushion the area around the windshield wipers and the lower part of the A-pillars. To deploy the system, there are sensors along the bumper edge. These advanced sensors have been developed to recognize an impact with a human-like leg form. This is unique technology, tailor-made for the new Volvo V40. The system has gone through extensive testing and computer-aided engineering in order to verify its performance. Performance both in different impact situations, as well as in different road and weather conditions. Along with our pedestrian detection with full auto brake, the pedestrian airbag technology is a grand example of how we work holistically with safety here at Volvo.
So you catch how we talked about auto brake. And I think it just repeats the same thing. So you heard him talk about it's combining with auto brake. Well, that's one of our autonomous systems we talked about yesterday. So here we're combining a pedestrian airbag system with a system that's going to automatically stop the car if the airbag's deployed. That's pretty cool.
That's amazing. Wow.
Isn't that amazing?
Yeah.
So this was originally engineered for Southeast Asia. Apparently, some of the countries along there have a real issue with that. Thailand and some of the other countries along there. So that's where this originally was developed for. So it is on cars in Australia. It's cars and it's coming to a city near you because obviously pedestrian deaths are an issue. And I thought was interesting is the bag is not there to protect the legs. It's not there to protect the hips. What it's really there to protect is the head. And you can see that by how the crash test was coming down on the vehicle. So they've identified not only how can we increase life, expectancy on a collision, but what causes people to die? And it's that head injury. It's not the broken legs. It's not the broken hips or these other things. It's the head injury. And this bag's specifically designed for that. So it is interesting to me that, a manufacturer, of course, Volvo is known for safety, and Volvo's not the only one doing this, but it is interesting technology.
It's funny to see that and you go like now to see it happen, and it's like, wow, it's doable. It's one of those things I don't know, just like to see it. It's really cool. I'm not wording the way I'm trying to, what I'm thinking, but it's really amazing to see developments come like that.
It is. And that's what keeps me excited after almost 40 years in this business is seeing new things like this that are like, wow, someone thought of this, and what, you kind of would have been laughed at probably 30 years ago or even 20 years ago for suggesting is now a reality.
Right.
You know, it really, I think it gets you thinking to what's next and where are the limits? You know, I mean, there's a lot of, you know, a lot of room to explore. Certainly the car that we have today is different than the car we had 20 years, 40 years, 60 years ago. What's the car 20 years from now going to look like?
Yeah, I forgot I wanted to mention too. It kind of ties in with this, but I rented a car a couple weeks ago,
Uh-huh.
and it one of the notifications every time I turned the car off would say to look in the back seat to remind you if you have children. You know, it was like a big SUV. I
Okay.
was really impressed with that too. It said check your you know, like basically like don't leave your kid in the car.
Right.
Yeah, I was like, wow, that's so impressive. You know, I mean, you know, just another simple reminder. Hey, you know, check your back seat for, I forget the exact words, but it was, I had never seen that before. And that's, you know, there's been deaths of children being left in the car or dogs or whatever. And I thought that was a
No,
really impressive little addition too.
absolutely. It is amazing that you know, it's amazing technology that someone put that in there because yeah, we do hear cases every year where someone dies because they left their kid in the car. They forgot they were there. I think the thing that's almost scarier, going back to what Dante brought up yesterday, is that as this new technology, we seem to become more brainless. It's
Agreed.
like, how do you forget your kid in the car?
Right.
You
Yep.
know, I mean, of course, we didn't have car seats when I was a kid, so it was harder for mom to leave me there because I was able to get out. But you know, still, it's just amazing that that our lives are so busy or we're so involved with other things that we actually forget our kids or animals in the car.
Yeah, it's a weird trade-off that we have to try to still be cognizant, or you know, do you think common sense, well, they say common sense ain't so common, you know.
That's it. And I think what's neat about this is that having the message telling you to look in the back seat isn't causing people to become, you know, less observant. That message is there because people are already less observant. So we're trying to solve a problem that's already there. We're not making a new problem.
Yeah, that makes sense. Yep.
So no, great point. And no, it's neat driving a new vehicle. I used to love it. I used to get flown up to Sacramento about once a month before COVID by the state. They, you know, they cover all my expenses because I was doing work for them. So, you know, airfare, rental car, all that stuff. And so I got to drive a lot of different new rental cars and play with a lot of stuff. And sometimes I'd bring scan tools with me. And I mean, I had one rental car I was playing with so much that I got it in the parking lot and it didn't want to move anymore. It's like, okay, I really messed this thing up. Let me see if I can get this thing back to life. And because I was really messing with it, trying to see how is it like this? What happens with this? And grabbing a lot of data and a lot of captures. And so it is really neat seeing some of that new technology or seeing some of the stuff you learn about that your own car doesn't have, but then go and, you know, drive a rental car and get to play with it. Or like my mom bought a brand new Subaru, I guess it's been 2 years ago now. It's probably a 2019. And it has all these advanced safety features on it. And she's in her 70s. And of course, she didn't want, you know, she just turns them all off, right? And so it was a neat chance to explain that, hey, some of these you want to leave on. This one I can see why it bothers you, would bother me too. But I turned them on and let the car drive itself, basically, with just me touching the steering wheel and let it handle the steering and the brakes. Made her about as nervous as a cat in a room full of rocking chairs. And because she's sitting next to me as I'm doing this, but I got to grab a lot of data off of it, play with it some, and I would just explain to her how it works. And she goes, I'm okay because you're here and you're doing it. And I know that nothing's going to happen, but it scared the heck out of her, you know, no confidence in that the car would actually steer or brake or do those things. Oh, well, go ahead, Rebecca.
No, so I was just gonna say it's like it's definitely a learning curve, you know, and uh yeah, I was just gonna add that little comment, but then I changed my mind.
Oh, okay.
Thank you though.
You bet. And Branko brought up a great question regarding the clock spring. What are the examples of suspension work that could affect this part? So the biggest example of suspension work that probably causes a problem is if someone changes the rack and pinion assembly or changes the steering gearbox, because that causes us to disconnect the steering column from the steering linkage and allows us to have that put together incorrectly. Another thing that might cause a problem with that misalignment is if someone has to put in a heater core or an air conditioning evaporator core where they're taking the dash out that requires you to remove the steering column. And now the steering column gets turned even though the wheels aren't turned. And now when it's put back together, it's not in the same alignment as far as rotations. And when you turn the wheel, you turn it too far and you break the little strip inside the clock spring. So those are the things that normally cause that to be damaged during service, Branko. Okay, so this next video I have to show you, let me kick it up on the share screen here. This is where we're using airbag technology in another industry. And it's pretty amazing. One of the things I like about this video is that it shows how fast this actually works as far as technology. And also you can see the little squib that they're exploding, how fast that works and how much force is being able to be applied. So this is pretty cool. This is from a table saw manufacturer.
Here is a good rule of thumb, or potential lack thereof. Table saws can bite. A quick demonstration. Wood. T-bone steak. Wood. Steak. Wood. Steak. Are we clear on this?
Yeah, there's about 60,000.
I'm not sure we can hear it. Can anybody else hear it? It's pretty low.
3,000 people take.
Let's see. I think I have it up about as far as it'll go. Let me. Yeah, I got the volume up all the way. So they just started talking. So the volume's not great on it.
Okay, no worries.
Okay.
60,000 medically treated accidents on table saws every year. About 3,000 people take their fingers off, about 10 a day.
Oh, 10 a day. Steve Gass, a lifelong woodworker, is trying to bring that number 10 down to 0. He has developed a system that stops the blade of a saw if it comes in contact with your finger. He calls it Saw Stop.
The system can tell the difference between your finger and the wood. So when you're cutting wood, if you accidentally run your hand into the blade, it'll stop it so quickly that you just get a little nick instead of maybe taking some fingers off.
The blade has a sensor that detects electrical conductivity. A piece of wood is not very conductive, so the saw goes right through it. A salty, wet finger is conductive.
Well, it's a lot like a touch lamp. There's a small electrical signal on there, conducts that signal into my body, and my body absorbs some of the signal. That triggers the system. It'll detect that in less than 1,000th of a second.
Okay. Any volunteers? Hey, over there in the fridge. Yeah. You. Yes.
Right.
We're going to use a salty, wet, conductive, all beef frank.
So I'll hold it just like it was my thumb.
You gotta be kidding me. Let's see. There's nothing. That is amazing. That really, I mean, that's it's like nothing ever happened.
The blade is rotating at about 5,000 RPM. It's forced to stop in 1/1000th of a second. It saves a finger, but mangles the machine.
You know, you have so much momentum in here. You're decelerating something at like 1,000 Gs. You know, 1,000 times the acceleration of gravity.
Now we get warped. Machine stops on a dime, or in this case, a franc. Machine is not happy about this fact.
Any way that this asymmetrically hits the weight, it's just going to put huge torques. You're slowing this thing down at 1,000 Gs. We just have no human reference to what that means. That's like driving a car 1,000 miles an hour and hitting a wall.
Yeah, concrete wall.
And it's just flapping like it's a piece of paper.
5,000 RPMs is a lot of energy. The energy has to go somewhere when it stops. So it's transferred to the saw stop module, which acts like the crumple zone in a car. The module and saw blade are now officially trashed. But hey, at a cost of about $60. Better to pay that than with a finger.
It's an amazing idea, and it's implemented in a way where you're using energy for its own stop.
Steve Gass is a true believer in his design, which brings us to our next demonstration. Steve is going to put his own finger into the table saw blade.
How are you feeling about this?
Well, a little nervous.
Yes, you knew we had to go for it.
I don't much like doing it, but it is such a unique opportunity. Let's do it.
There's not going to be a take two here. Having everything set right is crucial. As if you need a reminder, this is with saw stop. This is without. Without. That mask Steve is about to put on isn't a protection from spurting blood. It's to protect his eyes from the bright lights needed by our high-speed cameras.
You want to try putting your finger in there and just tell us how?
But you are never going to try this at home, right?
Yeah.
Right? Finally, lights, camera, conductivity.
You all right?
Yep.
There's no blood. There's nothing.
No, didn't hurt.
This is a man who has faith in his creation. Now we bet you've never seen this before, a finger being shoved into a table saw. At least we hope you aren't one of those unlucky 10. We know the machine stopped, and we know nobody got hurt, but we gotta say it. Ouch!
It felt a little like a buzz or a tickle almost.
You're talking about your finger in a table saw, and you're talking about a buzz and tickle.
We've done a lot of bizarre things in our lab, but somehow this demonstration of a man's faith in technology is one of the coolest.
That
Got too much other junk popped up on the screen. What did you guys think of that?
Amazing.
Isn't that amazing?
Yeah. Wow.
No, we learned that how much 1/1000 second.
Yeah. So 1 millisecond.
Yeah, 1 millisecond. Once we learn, it is amazing.
It is amazing. And it works on the principles we talk about in this class, which is the electrical principle and conductivity. And they put a current on the blade, and any change in the resistance of that blade basically sets it off. And so they're very, very sensitive, as I found out, because I was cutting a piece. Let's see here. Do I have anything? It doesn't have it. Let's see. Let me see if I have something back here. So this is probably a little hard to see. So this is just a piece of plywood. On one hand, you can see it's kind of dark on this side, and that's from cutting it with a laser. So this is, a piece of scrap wood from the laser. Well, I had a piece that we had tried to cut out, and it didn't want to cut well with the laser. So I took it out to the table saw to cut it. The carbon that formed from the laser cut, from it burning, was conductive enough to cause the saw stop to kick. And so it cost me a cartridge and a blade. So, carbon, we know carbon's conductive. And so is metal, so is, water, a lot of other things. But just the, heavy carbon where we had burnt it, trying to cut through a thicker piece with the laser, and it didn't want to cut because some of the material in the wood we were using. So I took it out to the saw to cut it and trim it, and boom, it conducted enough electricity to where it fired it off. So that was pretty amazing. I was surprised and disappointed because it was an expensive proposition between the blade and the cartridge, but it's a lot cheaper than losing one of these guys. So I'm good with it.
Hello? Skin repair.
But it is interesting how the technology we talk about in automotive really conveys over. You can see the explosive charge there. You can see how fast all that's happening. Now, pretty amazing. You can go from sensor to application that fast. Still don't think I'd be putting my finger into the blade.
I'm right there with you.
Yeah, I'm a big believer. Don't tempt fate, you know. I got this. I bought that a saw with that system on, or I bought that saw because I figured even for the price difference is way cheaper than a trip to the emergency room, and I like all my fingers. And when I went to school, and I was actually in junior high school, they still had wood shop in junior high school and high school. And I still remember our wood shop teacher talking about safety as he's holding up his fingers. And this is the guy teaching the class. So it's like, yeah, you know, we all knew the wood shop teachers that were missing at least one finger. So that kind of resonated with me. So entertainment, shift gears a little bit here. So as we mentioned yesterday, entertainment's changed a lot from humming to yourself as you drive down the road to now, you know, then AM radio, and then all transistorized AM radio. And then we started being able to listen to 4 tracks and 8 tracks and cassette tapes. Actually, somewhere in there before then, you could actually listen to records in a car. They had record players in the 1950s that you could put in a car. And now what do we have? We have CD players, MP3, you know, iPod control, Bluetooth with your phone, multiple speakers, lots of controls, extra bass, amplifiers, tons of stuff. So radios have changed an awful lot over the last 70 years. Today, vehicles are equipped with touchscreen LCD displays, DVD players, satellite entertainment systems. We can watch movies going down the road and not from a video cassette. Although there was a time when we did that also. Integrated Bluetooth, cell phone connection, hands-free communication are also present. I enjoy the heck out of hands-free for my cell phone. I drive when I go between here and the college, it's 55 miles each way. And so that left me time to make phone calls and talk to family or take care of business or do other things. So being able to be hands-free and make use of that commute time is huge. So, I mean, I drive to work, I leave here at 4 in the morning to get to work at 5, to get down to school at 5. I'd call my daughter who lives in Virginia, 4 in the morning, that's 7 o'clock her time. So we have a chance to talk. So, I mean, so, you know, the Bluetooth technology doesn't just buy us convenience and safety, obviously, because we're not staring at our phone, hopefully, while we're driving, but it also buys us time. It buys us the ability to use that time to continue connections or to take care of business or, you know, sit on hold for 20 minutes for something you need to deal with or whatever, because we're already in the car. We're already going to our destination. Now, how can I use that time more efficiently? Or do I just want to kick back, relax, and listen to music or listen to a podcast, you know? And that's the great thing about it. We're in the car by ourselves. We have those choices. Or do I want to use the infotainment system to entertain my kids so they're not driving me nuts? So as we talk about types of systems, basic system contains a head unit for control of the radio CD player along with inputs for MP3s. Complex systems incorporate satellite entertainment, DVD players for passengers, game consoles, multiple LCD screens, amplifiers, complex speaker systems with bass drivers, you know, et cetera. We're really, I don't think we've hit the limit for infotainment in the car by any means. So the head unit and the dash is the main control module, common on modern vehicles for navigation system to also be built into the infotainment system. So this is a heavy duty computer on a network that's sharing information with other computers. So a lot of vehicles today, the sound volume changes based on your speed. So as you're going faster, the sound will get louder. You don't really notice it, but it gets louder to disguise the other noises that you hear. And then when you come back down to a stop, it's quieted itself back down. So not everyone around you for 4 cars away hears everything you're listening to. And it's not too loud. Older systems, you'd end up turning it up going down the highway and then turn it down when you get in traffic. Systems are doing that automatically now. So they're adjusting the volume based on vehicle speed. Cool technology. Also, we see where messages are coming through the infotainment system. So it, not just a light on the dash, but it's able to give you a message through that infotainment system. Phone calls come through the infotainment system. So we're really integrating all these things, and then a computer is deciding what's the most important thing to put through the speakers. So here's an example. They're using the word modern. Well, 20 years ago, this was modern. Modern entertainment systems include screens for showing movies, allowing video games to be played. So this is probably 20-year-old technology, early 2000s minivan. So most modern vehicles integrate the radio video communication systems into an in-vehicle network. Controls are centralized with hardware. Communication between the components require a combination of hardwiring and data buses or a network. The data buses warning messages to be broadcast over the vehicle's audio system, and audio controls functions are usually located in the central control pod or on the component's control head, but also where? In the steering wheel. Most cars today, if you have steering wheel controls, you have a volume, you have the ability to change stations, all that stuff from your steering wheel. So you're not having to take your hands off. So steering wheel, those aren't just switches. They're going to be connected to a module, or they're modules themselves. So we're going to have a network system. So where we used to just have a simple radio that hooked the power and ground and went to 2 speakers, now we're getting much more involved. And here's an example of a system where we have a center console. I've got a bazillion speakers. I have an amplifier for the subwoofer. You can see it's dated because they have a CD stacker there, and we normally don't see CD stackers anymore. So this is even old. But we have our steering wheel controls and a clock spring that those controls have to go through. And that's another thing. If I think I have a bad clock spring, usually the horn doesn't work and any steering wheel controls don't work either. So not only do I get an airbag code for the driver's airbag, but none of my steering wheel controls work and my horn doesn't work. So that's a big clue, and none of those things work. It's a clock spring because it's all going through that. We can go to auxiliary functions. You can see here I've got climate control functions in here, radio functions, phone, and then I've got rear screens, antenna module, and I've got a network. And here they're showing it going between a body control module. Here goes to diagnosis. I can tell you there's going to be other modules on this network. Today, a CD stacker would be its own module. The amplifier is its own module. Those are all on the CAN circuit or on a network circuit. They're not individual units. They're not working in a vacuum. So all that's being networked now. Another function provided by the body control module is that of the speed dependent volume that I just talked about. Vehicle screens for onboard TV, DVD, and games can be located in the dash. If the screen is viewable by the driver, it must be disabled once the vehicle is in motion. Now, I'll be interested to see how that changes as vehicle autonomy increases. If I have a level 4, level 5 autonomous vehicle, why can't I watch TV if the car's driving and I don't need to do anything? Fair question. Control modules can be hardwired or wireless. There are no wireless control modules on a vehicle. So the only wireless stuff we have connected is through Bluetooth, things like that, like our cell phone. So on a vehicle, we are not using any wireless modules. The book infers this. The book says the control modules can be hardwired or wireless. There are no wireless control modules on a vehicle. We don't have any wireless networks on a vehicle at this time. So diagnosing the entertainment system, first thing it says testing will have to be guided by manufacturer service information. Okay. What I can tell you is there's normally no flow chart on how to diagnose an infotainment system. You get a wiring schematic. You might get some information on normal function of some of the components. That's it. So you're down to being able to read a wiring schematic, use some common sense. What does an amplifier do? What does a radio do? What does a CD changer do? What does a speaker do? And so on. And that's about it. We don't get a lot of help when it comes to infotainment, when it comes to diagnosing. Years ago, I had a Lexus in the shop, and the radio, even if you turned it all the way up high, was really quiet. And that was the customer's complaint. So I'm looking at the wiring schematic, and I see it has a radio and it has an amplifier. Well, a radio to the speakers is going to put out a signal, and I could tell all the speakers made noise, but they were quiet. So, and that's all the information I had. That's it. Here's a wiring schematic. Here's your components. Good luck. And I said, well, if it's an electrical signal, I can see it on a lab scope, because I know a lab scope measures time and amplitude of electricity. And I know that the wires going from the radio or amplifier to the speakers are carrying electricity. Ergo, I know I can see it. I don't know what it looks like, but I know I can see something's going to get on the screen. So let's put something on the screen. So I connected to the positive and negative side of the circuit, just like a speaker would be. And sure enough, I got this wave going up and down. And since I could hear the music, I could see when the music got loud, it went high and then down. And so, okay, cool, I can see this. So then I looked at the wiring schematic, and all the speaker wires went into the amplifier and then came out of the amplifier. So I went in the amplifier and I'm looking at the signal, and it comes up about this high going in. And I look at the signal coming out of the amplifier and it goes this high. It looks the same. Well, amplifier means make larger, doesn't it? Make bigger, amplify. So there's no specs, but I mean, it's the same, and it shouldn't be, and it's plugged in and has power and everything. It's not amplifying. It's not making bigger. So I put a new amplifier in it. And of course, it was only from the dealer. It was like $450. And this is 20 years ago. And it was a couple days away because they never sell them. And so I'm kind of like, oh, gee, did I fix it? Did I fix it? Did I fix it? And sure enough, I plugged it in. Now the radio was loud. And I was like, oh, I fixed it. Great. And I put the lab scope on. And sure enough, you could see low. And now I've got this huge signal coming out. So I have the low signal in and a huge signal out. It's amplifying. Well, I didn't fix the car because I'm smart. I fixed the car because I asked good questions, applied common sense. And the most important question I asked is, what would happen if I do this? I should be able to use this to see something. Now that I see something, what does what I see mean? And can I use that to compare at different parts to see what's normal and what's not normal? So that's the limit of how much help you get on entertainment systems normally. None. So that's why asking questions is so important. You know, what does this device do? What is the name of the device? What's it supposed to do? And that is, and now how can I measure what it's doing? And a lab scope is great for that, because I can see the electrical signal, and now I have something to compare or look at and try to make sense out of. So problems can range from low speaker output, like I just mentioned, but poor radio reception, failure of the GPS system. So poor radio reception. Does it work good on FM but not AM, or good on AM and not FM, or does it not work at all? Is there two separate antennas or only one antenna? Some cars have a separate antenna for FM and AM. So again, we're going back to the wiring schematic, and it's about asking questions. How does it work? What's not working? What does work? What components are available, and what makes sense to go look at? Always verify the concern. That's true with any diagnosis. Research the service information to develop a focused testing plan. If there's no radio reception issue, check the radio by selecting a station you know comes in well in your area. Change bands. Put a CD in it. Does the CD play? Well, if the CD plays, that means the speakers have to be good, means the control head's good, means the buttons are good. So I don't need to worry about speakers or that. So now it's, why isn't the radio working? Is it not making any sound at all, or is it making sound but not music? Okay, it's making sound but not music. That sounds more like an antenna issue. It's not making any sound at all. That could be an antenna issue. It could also be a tuner issue or something like that. So, it's kind of about asking those kinds of questions to prove what is working, so you can concentrate on what might not be working. Check for good power and ground connections. Use a lab scope to detect any unwanted ripple or noise in the power circuit. Again, that's our AC ripple that we get from the alternator. I can check that out at the battery. Occasionally we get RF interference, but we're not going to really see that on the power wire. We might see that on an antenna wire on occasion. Ensure the power connections are clean and tight. Check the antenna for corrosion-free connections. Now, this all sounds great, but some of these connections are just not accessible. So we don't have time to go around and checking everything or looking at everything. That's why we need to verify the condition, try some things, and start asking questions about what's not my problem to what could be my problem, and only test what could be my problem. If the problem is a video device, verify the concern just like any others. So in other words, the DVD player doesn't play. And okay, does everything else work? So then we're now, does the radio even talk to the DVD player? Is the DVD player just broken? Does it have power and ground? And Branko's question, is the antenna just a plain wire, or is it something special? It is something special. It's a coaxial cable. So it's going to have, just very similar to the coaxial cable that might go into your house, has a center connector and then an outer sleeve. And so it's a coaxial cable where the outside of the cable, it's round, and the outside has the ground part, and then the center is the positive. And so that's going to go into a connector and join both at the same time. So that's a special coaxial cable that's used for the antenna. And it's a special antenna collector that's just a slip fit connector. Normally, occasionally you'll see a screw on one, but those are rare. But it's still, they all still have that inner and outer. So the outer is the ground, the inner is the main conductor where the signal's coming through. So we can see that. Again, two wires. We can hook a scope up. We can look at that, see what's coming in, or if we have anything on the antenna, but that's what's being brought in. So sometimes it's a bad connection. Sometimes the coaxial gets pinched. Sometimes people think it's a regular wire and like tried to poke to get an electrical signal and ended up shorting the two together, which is rare, but it happens where someone's working on it, doesn't understand what they're working on. So antennas are not a huge failure item. Occasionally they do go bad, but more commonly it's a connection issue at the antenna. Also, we have power antennas that automatically go up and down when you turn the radio on or turn the radio off. They routinely get torn out at car washes. So some antennas, I can replace just the mast part of the antenna that goes into the motor. And you either have to disassemble them to install that on Asian ones, or on European ones, I can actually just feed a new mast in without taking everything apart. And I can do that 2 or 3 times before I have to disassemble it and get all the pieces out. So we have the metal antenna on the outside, but then we have the coaxial cable coming through it. Also, some antennas are in windshields. So I don't have an antenna sticking up anywhere in the car. It's actually built into the windshield. GM did this going back into the 70s. I also may have separate antennas where one might be the vertical antenna and one might be in a piece of glass or on the roof, depending whether I'm looking for AM or FM. So that's why it's real important. If, hey, I don't think the radar's working right, great, try a couple different stations, try a couple different bands, because you're trying to figure out where the problem might be. Good question.
So could it be sometimes a rat damage, for example, for the
Oh,
antenna?
yeah.
Okay.
Oh, absolutely. Rats can damage anything.
Mhm.
Yeah, the rats and squirrels up here, they'll eat anything.
Thank you for the thorough explanation.
You bet. Okay. So satellite communicating global positioning system. So a lot of you have heard of GPS. GPS was originally developed for the military. It's a system of 24 satellites, and you can use 3 of those satellites to triangulate a position anywhere on the Earth, as long as you're able to see the 3 satellites. So GPS doesn't work in tunnels. It doesn't work underground. It doesn't work in places that we can't see the satellites. It is able to go short distances because of the software that we have in vehicles, to where it doesn't necessarily lose connection every time you go underneath a bridge, because it has a certain amount of buffering and it knows what direction and how fast you're going. So it can still kind of plot you on the navigation, even if it intermittently loses connection. So the use of satellite technology in vehicle systems provides an ever increasing array for vehicle manufacturers. So we have position, we have navigation, we have vehicle tracking, theft recovery, communication, internet access. So we use this a lot for heavy duty trucks. So for heavy duty trucks, I can not only know where the truck is, I can know how fast it's moving. I might have a video feed that shows me not only the view in front of the truck, but also a view of the driver. And that's all in real time. I can communicate with the driver in real time. I can see how the driver is driving when they get off the freeway and go through a city, to see if they're following the rules or following the etiquette that I want for my company. I can, immediately discipline a driver. I could, increase or decrease a vehicle's maximum speed. So some states like Montana do not have a maximum daytime speed limit. So I might let my truck go to 80 miles an hour during the day in Montana, but as soon as we get to the end of Montana, we need to only do 65. So I can change the parameter of the truck that allows it to go up to 80 in Montana. And as soon as it's leaving Montana, oh, gee, now that state, that's only allowed to be 65. So we're going to change the truck so that now it can only do 65 miles an hour. And this is all happening to a fleet of vehicles in real time. It's really pretty amazing technology. A vehicle could be sensing a problem, like a check engine light, and we're able to access the data, see what the code is, determine, can the vehicle make it to the destination? Is this something that needs to be taken care of now? If it can make it to its destination, do we have time to get it in there so we can already schedule an appointment and work on getting it serviced? If the vehicle breaks down in the middle of the Mojave Desert with GPS, we know exactly where it is. And we see that not just on commercial vehicles, but also on, with OnStar, and BMW has a similar service. I think Ford does also. Quite a few manufacturers do, where they have a satellite system with the GPS that, airbags are deployed. We can call 911 for you. I mean, there's the ability for the vehicle to communicate back to the infrastructure is huge when you look at safety. I mean, you think about it, 20 years ago, if you broke out down in the middle of the desert, you're hoping for someone to come by. And if you're not on a main road, that might be a while. Where now, GPS is there. We can get, even if there's no cell phone coverage, and go through the satellites and respond and get someone out. And what's more, the person looking for you can find you because they have GPS also. So really amazing advances in technology. vehicle theft. You know, a lot easier to find a lot of these vehicles now because they got GPS on them. We can find it. So here's an example. So most vehicle tracking systems work very accurately for short periods of time without satellite communication once their initial position has been determined. Onboard sensors such as vehicle speed and steering wheel position sensors can be used to keep track of the vehicle location until satellite communication is reestablished. So we've used GPS. What we're starting to, in combination with GPS, we've used cell phone towers. With 5G, and part of the big push for 5G is so the vehicle will communicate with the 5G infrastructure. So when we look at autonomous vehicles, we want the vehicle to be able to call home, right? I got a problem. I don't know what to do. What's going on? Then we want the vehicle to be able to communicate with the infrastructure. Infrastructure being the signal that's a block away, the signal that's 2 blocks away. So when is the signal that's a block away going to turn green? Based on my speed, I'm going to be there in 45 seconds. Well, it's going to turn green in 1 minute. So what an autonomous vehicle would do would be to slow down. So when it gets to that signal, it's going to be green and it doesn't have to come to a stop. Or the light's green, I'm going to be there in 45 seconds. It's going to turn yellow in 20 seconds. We're going to already start slowing down because we know we're going to have to stop. So you can see by looking ahead and talking to the infrastructure, we're going to have a lot more traffic calming. And the idea is that traffic's going to move more freely because it's not going to be that, race to the next red light. It's going to be more of that methodical, here's the speed I need to do to get all the lights green. And so you're going to have, and there's a real desire, and we've already done this at a prototype in a few cities where we're using vehicle to infrastructure. The last part of autonomous vehicle, when it talks about communication, is now using that 5G network for vehicle to vehicle communication. So if you have autonomous vehicles, they know where they're going. So now instead of coming up to a stop sign and going, I'm on the right, so I'm going to go, but am I going straight? Am I making a right turn? What's going on? If vehicles are already to integrate their destination and where they're going, think about how much more seamless a lot of driving would be. You wouldn't have to be waiting for some of those signals that us as humans have to send back and forth when we finally get there, because those decisions would have been made prior to getting there. Which is another reason why you see, aside from the efficiency of the circles that they use in Europe, we're seeing a lot more of these traffic circles here in the US. They really lend themselves more to autonomous vehicles as opposed to a stop sign. Stop signs are very hard for autonomous vehicles because people don't follow the rules. And the autonomous vehicle can't see what your eyes and facial expression are telling you. So that's why these traffic circles are much more efficient for autonomous vehicles. So you think about what we have currently is we talk to satellites or possible cell phones from the vehicle, and it's a subscription service that we may or may not want. Some services are there whether we want them or not, they're just not activated. Then you're going to get to where your vehicle needs to talk to infrastructure for it to work properly, and then talk to other vehicles. And that's one reason why you saw that timeline out to 2030 for fully autonomous vehicles, is they're working on these infrastructure, these communication issues. So triangulation, GPS relies on a group of at least 24 satellites orbiting approximately 12,650 miles above the Earth. Each satellite is equipped with an atomic clock on board and regularly transmits a unique radio frequency. The signal simultaneously from all other globally positioned satellites. In other words, all satellites send a signal out at exactly the same time. Each signal has its own signature letting you know which satellite sent it. The GPS operates on the triangulation principle. So the triangulation is a process of finding a position of an unknown point based on forming triangles with known points. So if we have these satellites and we know that they all sent their signal out at the same time, and we know where the satellites are, the time it takes for them to reach this vehicle, we can now precisely calculate where that vehicle is. Pretty amazing. Talks about here the GPS is accurate to within 25 feet. They're now more accurate than that. They used to have them less accurate. They were concerned about possible military use by military other than ours. So they had them not as accurate deliberately. And then as they become more comfortable with allowing that technology out there, they've allowed them to become more accurate. So now you can actually see almost what lane of traffic you're in on the GPS. So the vehicle's onboard GPS system needs three things to determine location of the vehicle: time it took for the signal to travel from each satellite to the vehicle, position of each satellite, and an accurate time. Which means your car needs to know what time it is. Inaccuracies can be caused by weather conditions. Inaccuracies also occur when radio frequency signals are reflected off of objects such as large buildings or due to solar radiation. So sun flares can affect this system also. So satellite-based navigation. Once triangulation has been determined, mapping software stored in the memory can be used to generate an overlay map. During normal operation, the computer program compares the vehicle data derived from the satellites with the onboard sensor information to ensure high levels of accuracy. Ground-based stations can be used as an absolute reference point. Satellite navigation features may include multiple languages and choice of voice gender, or multiple voices of each gender. Many also include directional information provided with a combination of screen icons, maps, audible instructions, and so on. This is neat. I like it when I travel because I can know, what restaurants are available at the next off-ramp, what gas stations. So if I'm traveling, I can plan ahead. If it's an area I don't know, which off-ramp do I want to get off at, where I can get everything I need at that off-ramp. Or it may have the brand of gas station I want, or the kind of fast food I want, or so on. So these are very popular. Although we still see them on vehicles, I think a lot of people use the software in their phone as opposed to paying for the information in the vehicle. I know when we got this on my wife's car back in 2005, it was very expensive, but it was part of a package, but it was an expensive package for the navigation. But that's before smartphones. So it totally made sense. Now with smartphones, a lot of people aren't buying the navigation package because they can get similar features out of the smartphone, just a smaller resolution, smaller screen. So telemetrics is a satellite-based system that combines two-way communication information technology within the vehicle, allows vehicle tracking, security features, monitoring of onboard systems, messaging, delivery of travel information, entertainment functions, all through there is a two-way. So now not only am I getting information from a satellite, I'm able to send information to the satellite. So many manufacturers offer this service to its customers, and the manufacturers have also used this as a great marketing tool. You might get a message or a phone call while you're driving, but it'd be a message through their satellite system, not your phone, saying, hey, we noticed that you're due for your 10,000 mile service in 300 miles. And based on how you drive, that's going to be in 2 weeks. Would you like us to schedule you into the dealership next week to get that taken care of? So a lot of manufacturers are using this as a marketing tool to stay in touch with the customers that have bought their vehicles, to encourage them to come back to the dealers to get those maintenance items done. Or also, hey, your check engine light's on and you shouldn't be driving. You need to call a tow truck, or your check engine light's on. Here's the code we have, would you like us to schedule you into the dealer? You can drive with it till next week. Don't worry about it. We'll get it, taken care of and so on. So we're now seeing where manufacturers through telematics are actually reaching out to customers to initiate that service visit. So here's just a picture showing the telematics and some of the systems that are incorporated into that. The system can include location and immobilization of a stolen or lost vehicle. So this is, and this has been used by a police. Someone steals a car, they can shut the car down. They've done this with GM for years. Cops are pursuing, here's the license, get all to OnStar, verify credentials. Yeah, shut the vehicle down and lock the doors, please. And they'll actually lock the doors, shut the vehicle down, and it comes to a stop. And then the police tell OnStar, okay, go ahead and unlock the doors. We're ready. And doors unlock and they get the people. So, talk about safety. We hear a lot about high-speed chases and the dangers of high-speed chases. Imagine if more vehicles had the capability of law enforcement just saying, yeah, the car that's doing 120 down the 5, here's a license plate. Can you just kill power to that sucker? Can you limit its speed to 15 miles an hour and then eventually stop it? A lot of things can be brought in. It's going to really change safety aspects for people that aren't involved and don't want to be involved with an incident like that. Yet look at how many people are killed because someone else is running from the cops in a high-speed chase or seriously injured. So, it would certainly, I would think, be a big advantage to be able to shut those vehicles down remotely. And we have the technology to do it. The technology is not employed on all vehicles, but the technology is there. Or you left your keys in your car on accident, or you forgot your keys. You could call and say, hey, verify your information, and can you unlock my car? Can you start my car so I can get home? Because I don't have my key with me. My purse was stolen, or my wallet was stolen, or whatever. And I don't have my key anymore, and here's my car, and it's locked, and I'd like to get home. So a lot of interesting possibilities for the technology. Anti-theft systems, we've talked about some before. We've talked about difference between an immobilizer and alarm. So here talks about things: theft deterrent, door locks, remote keyless entry, or remote start, starter fuel disable. So these systems are all individual systems. We're still using the same logic. How's it supposed to work? How did the manufacturer build it? And where do I go from here? So many anti-theft systems are on the network today, and I can actually get codes from them if they are preventing me from having the vehicle start. So devices or methods used to prevent unauthorized use of a vehicle or its component parts. So keys are authorized. Some manufacturers actually allow me to turn off keys. Mercedes started doing this 20 years ago. So say I give a key to someone for my car, and now we've had a falling out and we're no longer friends. And it would be very awkward, if not impossible, for me to get the key back. Well, now I can just go by and have that key turned off. That key is no longer going to work my remote locks. It's no longer going to start my car or move my car. Problem solved. So, that technology has really evolved a lot. Many manufacturers incorporate a number of technologies into a single vehicle to discourage the theft of vehicles. So anti-theft devices and features help detour vehicle theft. So here's someone using what's called a Slim Jim to unlock a vehicle. And in the old days, it used to be really easy. You need one Slim Jim, you can get into about anything. When you would slide it down, it would catch the linkage for the lock, and you'd pop it up, and then you can unlock the car. So what manufacturers started doing is putting a metal plate over the linkage. So now when you slide it down, you hit the metal plate, you could no longer get to the linkage. That was an anti-theft So then what we had to come out with different designed lockout tools to get around that, different ways to do it. A lot of times now they actually use balloons and they actually pry the door open a little bit, go in and reach to get latches or hit buttons. There's a lot of different ways to do it in a lockout kit. But again, it sounds really low tech, and it is, but it's a constant cat and mouse. As technology evolves, so does the technology to get around the technologies that's preventing the car from being stolen. So, you know, it's a constant evolution, and we've seen this over the last 40 years. So types of anti-theft systems: theft deterrent systems aim to prevent the vehicle from being entered, started, or driven. Actuators used to achieve this are electric door locks and windows, starter motor relays, engine management systems, transmission shift solenoids, an audible alarm. So some cars you can get into, get it started, but the transmission won't shift because it's part of the theft deterrent system. You're stuck in park. Great, congratulations, you got the engine to run. Theft deterrent systems can be divided into 4 categories according to the book: component identification, vehicle locking, including keyless entry and remote starting, engine and transmission immobilization, and audible and visible alarms. So component identification, this is something that is fairly new, you know, last 20 or so years. Manufacturers etch the vehicle identification number into labels that are attached to various components on the vehicle. So one of the issues that there's always been with stolen cars is they go into a chop shop, and once the car is disassembled, it was very hard to prove those parts came from a stolen car. So now what we see is etching the VIN into all the windows. Microdots are used, small plastic particles that have either the VIN or a unique number printed on them. They can be seen by using ultraviolet light and a magnifying glass, mixed with an adhesive sprayed into the underside of the vehicle, wheel wells, engine bay, different components. So you can see what they did is that a lot of the parts on the car that they used to take apart and sell all of a sudden don't have value now because they can be traced back. They can be checked. So it's no longer as lucrative to steal a car, cut it up into pieces, and sell off all the parts. So consequently, what we see a lot of now is either people stealing parts off the car, or some cars are stolen and sent out for export complete. But the days of the chop shop, as it was 40 years ago, are really kind of gone. Do people still get cars and still divide them up? Yeah, I'm sure they probably do. But it's not what it was. And that's because now if you get caught with a bunch of parts, they can prove that they're stolen parts. And where'd you get them from? So they've been able to prove that auto part stores that were dealing with used fenders, used, components like that, that they're actually stolen, and put those people out of business. So a lot of these shops lost their customer, right? There's no place to sell it. Things are only worth what you can sell them for. So if no one wants to buy it, it's not worth much. Vehicle locking: a security system automatically locks the doors once the vehicle has reached a preset speed, and normally will stay locked as long as the vehicle is in drive. So again, safety, prevent someone just from hopping in your car when you get to a stoplight. Deadlocking adds a further level of security. In keyless systems, remote control keys and key fobs transmit coded signal that is received by the vehicle's theft deterrent module. If a code meets the criteria, the module either enables either the driver's door or all the doors to be unlocked. High frequency electromagnetic fields are used to exchange information. On some vehicles, when the key is beyond a certain range of the vehicle, the anti-theft module locks the vehicle. So in case you forgot to lock your car, it locks it for you. Other one can be set on time. So it'll set after a certain period of time, it'll automatically lock the doors. And these are normally things the customer can change. So if you don't want your car to automatically lock itself, If you open up the owner's manual, there's usually a way to disable that feature. Or if you do want it to automatically lock itself, as soon as you take the keys out and you shut the door, there it'll automatically do that. You can change that. So those are things that normally the driver of the vehicle, the owner of the vehicle, can change and are in the owner's manual. Personalization of the system is possible in vehicles with keyless entry. This allows different settings to be made that are unique to each driver. So we also have the capability of programming some vehicles to act differently based on which key is used, down to the position of the seat, what radio station, which doors do you want unlocked, you know, and even down to how's the vehicle going to drive as far as, you know, some of the tuning characteristics of the engine and transmission based on your driving habits or the driving habits of that key. Engine and transmission immobilization. Immobilization occurs when the theft deterrent system prevents the vehicle's engine from starting or the transmission from operating. Audible and visible alarms may be activated, but the alarm is not an immobilization system. It's an alarm system. Now, they may be intertwined. They may even use the same computer, but they're separate functions. Operational characteristics vary greatly among manufacturers, and most systems use a coded system known as rolling codes. So this allows manufacturer to not be hacked. In other words, there's a rolling code. The code changes every time the car is started. There's 256,000 options. The coded data transmitted received between the key fob and the theft deterrent monitor computer change randomly. So again, 256,000 rolling codes. So some systems use a fixed code. This is the code for this key all the time. Those are the cheaper systems. Some high-end systems use a rolling code. Needs to say higher end system means higher priced car. System allows for an error factor of 25 steps either side of the agreed code for deactivation. Yeah, I would say that's I don't know where they got that from. Vehicles can be equipped with alarm. An alarm may not have an immobilizer. It may just be something that makes a lot of noise if someone's trying to steal your car or driving your car away. A lot of early European cars, 90s vintage, in 80s vintage, you could hop in the car and drive it away and the alarm's going off. Yeah, the alarm works fine, but there's no immobilizer. We have cars today that have an immobilizer and no alarm. And then we have cars that have both. But it always amazes me. We have all this technology in a new car, and yet the dealer's trying to sell you a $300 add-on alarm on top of your new car. And my car already has way better technology in it. Why would I buy that? And I love it. They went ahead. Well, it's already installed. Okay, let me think about this. You've installed it in all of them on the lot, and just disable it so it's there. And I've still got it in my car that I don't want. How much can this thing be worth when you're willing to pay to put them in every car, and you only get paid for how many of them, and it's still a good deal for you? So like when I bought my new car, I actually made them take the thing out. I said I didn't want it. Well, it's already in there. I don't want it. I'm buying a new car. I'm not buying a new car that's been modified. I want it out. And actually, because they use a separate alarm company, they actually made the alarm company guy come down to my work and take it out at my work because I wasn't taking the time to take the car back and get it done through their service department.
So in that scenario, what happens with the stock alarm? So they added something, some other system.
Right. And the stock alarm's still there.
But what activates when alarm is triggered?
Well, the stock alarm is still there. They've usually either deactivated, turned it off, or it's still there. And then you get another alarm with a fancy little key fob that's your aftermarket alarm that's wired into the system. It's like, it's completely redundant in many cases. And
you're saying it could be a lower end than what is already.
Oh, absolutely. I mean, you think about it. If they're charging you retail of $300, they're getting a deal on them that maybe they're getting them installed for $100 a piece, $125 a piece, because they're not selling every one. And the guy installing them is making money installing them. What's the alarm cost? $40, $50, and that's his cost. cost to manufacture $5. You know, I mean, when you drill it down, how good can it be?
Not very good.
Right. There's just not enough money there. I mean, if they're willing, when I don't buy it, they're willing to leave it on the car and then just disable it. What does that tell you? I mean, how much value can it have? You know, I mean, things that are valuable, you want back.
Yeah, good that you had it disabled.
I had it removed. It is gone.
Removed.
And that's something that car dealers still do today. They're still putting those aftermarket alarms on because it's something they can try to sell you at closing if you're buying a new car or even a used car.
A separate question, Mr. Brian. Even older cars like my 2003 Civic have these key. I don't know. I don't think you maybe came to that point, but there's that chip inside the key, right? A classic key.
It may, yeah. 2003 certainly could.
Yeah. So I also, we have a 2007 Ford Focus, and same thing. So it has that.
Yeah, I know the Ford does.
So how can you even steal a car like that?
You really can't. You know, there is some things available, some cloning devices where they're able to clone some keys and do some other things. But, you know, really the only way to steal a lot of these cars is with a key. I mean, you saw the movie Gone in 60 Seconds with Nicolas Cage. It was all about getting keys off of the VIN and being able to get in and start and drive the car. And because at that time, they weren't coded quite the same way. You could go in and you could start the car. So, yeah, a lot of these cars now are difficult to steal without the key. I'm not going to say impossible because cars do still get stolen. But what we're finding now is people are more likely to steal parts off the car, such as the catalytic converter, than take the whole car. And part of that's a technology issue. I mean, professional car thieves can steal your car. I mean, some cars we look at and go, the only way to steal that's with a flatbed. But, you know, like with any technology, just like, you know, they figure out a way around things. It's a matter about how much money you want to spend doing it. But what it does is it eliminates a lot of the kids and a lot of the not professional car thieves that would, you know, steal cars because it's a chance to get some, you know, some quick money or take a joyride. So it's really eliminated a lot of that. And it's down to, how are you going to steal it? Well, number one, people steal cars as the keys are left in it. You know, or someone has a hide a key on the car and they found it, you know, because there's only so many places people put a hide a key. So it is difficult, again, depending on the level of the car, to where I would say impossible without the key or cloning the key. And they do have stuff that is able to clone a key and mimic a key. And it's some kind of high-tech stuff. But they can actually scan for a key in the house or within range of the key, get the code out of it, and then mimic that code to get the car to start.
Okay.
So there is, you know, professional, I want to steal stuff out there, right? But that's the exception and not the rule.
Okay, thank you. I was wondering, like.
Yeah. Good questions. So basic alarm systems can be triggered off door switches. Also, you might have trunk and hood switches. Also, normally there's what's called a glass break sensor. Something's going to measure that shock. And there also might be a mercury switch that measures if the vehicle's been shocked or vibrated or moved greatly. Vibration sensors, ultrasonic sensors, voltage monitoring sensors. So again, you can get as evolved as you want. Diagnosing these systems, we're looking at technical service bulletins, scan tool. Most of these new systems for the last 20 years, there's going to be some data available through the onboard diagnostic system. Now, in order to access it, you're probably going to need what we call an enhanced scan tool, which is that factory level scan tool. That's not necessarily a dealer scan tool, but it's not the $70 or $80 code reader. It's not going to get you there. You need that higher level tool. And again, a lot of it's about common sense. The biggest fault problem we have with alarm systems is they don't turn off and prevent and the immobilizer keeps the vehicle from running. If it's an aftermarket alarm system, normally it's just a bad alarm. We just take the alarm out. We're not going to diagnose an aftermarket alarm as a rule. So factory alarm will diagnose because I can talk to it. I can get information out of it, parts available. Aftermarket alarm, if it's preventing the car from starting, we just rip the whole thing out. Done. Here's your aftermarket alarm. It's in a box. Your car's fixed. It starts now. Done. We don't fix aftermarket alarms as a rule. We just pull them out. Because most of them I can pull out for an hour labor is normally what we charge. And I spend an hour or more trying to diagnose this old thing that's probably broken. And what normally happens is the little module goes bad on them anyways. So consequently, aftermarket alarm, we just take them out. And what's interesting is a lot of times it's people that didn't even know they had an alarm on a car. They had no fob. They've never used the alarm. But just like my car, someone bought it, had an alarm in it. They disabled it. So the alarm's turned off. And then something happens. And sometimes something happening can be as simple as a battery going dead. And when the battery goes dead, the alarm automatically arms itself. And you have no way of disarming it because you don't have the key fobs. A lot of them have a rocker switch in that you can kick it into that mode. They're supposed to be installed with one. You got to figure out where they put it and you can kick it into that mode, which turns it off. But that stops working after a while sometimes. Not the switch, but the circuit inside the module. So we end up taking them out a lot of the time. If we can't just hit the switch and reset it, they get taken out. And that's why I wanted mine removed. I didn't want to deal with it in 8 or 10 years when the module goes bad. So hopefully I gave you guys a good overview of some of our communication and safety systems on the vehicle and of our airbag system and also on our autonomous driving. Now the videos that I showed you, I do have the videos up in Canvas. They're in this module. I think it's 4.1.6, I think is where it is, but it's at the end of the information for module information. So if you want to see those videos again, that's where they're at. They're also up on my YouTube channel of the videos I made. And so hopefully you guys learned a little bit about the system. Like I said, this system is not overly technical. It's more about theory and more about what we're doing and about some places I think we're going and some places we've already come from, and just kind of so you can understand what these systems do. So as I mentioned, this was not a terribly technical module. Our next module is going to get a little more technical. We're going to talk about networking. We're going to drill into networking and really see how it works. And some of that drilling in gets a little technical, but we do that because we actually have to diagnose network systems. And then we're going to get into sensors and actuators and computer function. And that PowerPoint ties into a couple different chapters in CDX. One you already did, chapter 52, and the other one is a chapter in ASE 8 in the engine performance section where it talks about sensors and actuators that we haven't gotten to yet. So I really kind of have broken it down to try to simplify it. We don't have that many different sensors on the car. We don't have that many different types of actuators on the car, and we only have a couple different ways we can turn them on and off. And so my presentation really breaks it down to what sensors we have, how they have to work electrically, how we test them, what kind of actuators we have, how do we turn them on and off, how do we test them. And from there, taking probably 8 sensors accounts for the thousands of sensors we have in the car, because there's only 7 or 8 different kinds. So we're just going to try to break it down to here's what it is. So as we move forward from this chapter and we start getting into engines and then engine performance, you're going to see other sensors, you're going to see other circuits. And I'm just going to relay back to what we talk about in the sensors and actuators presentation in module 5. And I'll probably get to that on Monday, sensors and actuators. I'm going to do network first starting tomorrow. And everything comes back to that. Everything's going to come back to those basic electrical circuits and basic how we turn things on and off. Because I can't teach you everything they're going to come out with next week, next year. and we've got 1,700 different models with a lot of different names of exactly the same type of thing. But once we understand what it does and how it has to work, now we can figure out that the same sensor we're using to control the engine is the same sensor we're using to control the ride height, which is the same sensor I'm using to control how much air you get coming in your face out of your climate control, and so on. So once I understand it's the same sensor, now I understand what the computer is looking at from the sensor, and now I just use logic. Why does the computer want to know how high the car is? Why does the computer want to know where the door position is for between hot and cold? Why do I, those are pretty easy things to answer, right? If I ask for 68 degrees, we're going to blend some air depending on how warm or cold it is outside. And so the computer needs to know where that door is. We need to know where your foot is on the gas. We need to know where the throttle position is on the engine. So we have these sensors that are the same sensor. We just use them a lot of different places and call them a couple hundred different names. So instead of learning all the names, in each sensor is its own unique sensor like nothing else in the car, why don't we just drill down to what they do and how they have to work? And then we can just, as we learn new technology, we just go, oh yeah, we're using that here. Oh, they drug this up and used that here. We already know how the hard part of it works, and we can just concentrate on the theory of the new thing we're learning. And that gets us through the rest of the systems on the car. So with that, if no one has any questions or comments, I'll let you guys out a little early today.